Alright, we're going to start talking about the conservation of momentum. And basically momentum conservation says that the momentum of a system never changes. So you can't create or destroy momentum. So when we talk about a system, we talk about a collection of objects. And it will always stay the same so long as we're only talking about those objects, so nothing's going to come in or out. So I can have, say, a object here, say a box, right, has a mass of, let's say, 20 kilograms. And let's say I have another box sitting over here, and let's say it has a mass of 10 kilograms. So two different boxes. So this is going to be my system, okay? So the system is never going to change. And we talk about that. I like to kind of take these objects and kind of put them in a box. Alright, so that's my system. Alright, we're only going to look at those two things. Nothing's going to get in, nothing's going to get out. We're just going to look at what they're doing and see how that momentum then is conserved with that. So let's start this one off here. So let's differentiate. Let's call this mass 1. Let's call this mass 2. Right? So box 2, box 1. Let's have box 1. Let's give it a velocity of about 40.9 meters per second. We'll have it cruising here towards box 2. Right? So 40.9 meters per second towards box 2. Let's have box 2 just sit here. Let's just start it off with 0. It's at rest, 0 meters per second. So we'll have these boxes here. So obviously if you look at this, box 1 is going to cruise along here and run into box 2. And so let's look specifically at an elastic collision example on this one. So this one's an elastic collision. And if you recall, elastic collisions, essentially the objects will bounce off each other. Alright, so we'll have the collision take place, so collision, they collide. And we'll look at this now. Box 1 and box 2. So if box 1 hits box 2, right, it's going to apply a force to it. So there's going to be a force applied. And when it does that, third law says it's going to apply a force back on box 1. So box 2 here, which has no initial speed in this case, is going to have some force applied. It's going to accelerate. And box 1 here that was heading towards the right now has a force applied to it in the opposite direction, back to the left, so it's going to slow down. So let's take a look at what happens. Let's see what the resulting motions are here. So it turns out in this collision then, box 1 is going to end up with a velocity of about 13.4 meters per second. Still going that way. Alright, so it's slowed down from its 40.9 meters per second. What we want to figure out is, well, how fast is box 2 going to be traveling now after this collision? So we have the before, we have the after, right? Our collision. Again, we're still looking at the system of just these two boxes here. So in order to do this, we're talking about conservation of momentum. We have to look at the fact that the total momentum here before the collision never changes. So the total momentum of box 1 and box 2 together is going to be the same here as it is down here after the collision. So we need to figure out the momentum of box 1 and box 2 in this system here. So momentum is just, let's do this right up here. So the momentum of box 1 is going to be its mass times its velocity. Right? So in this case, the mass is 20 kilograms and its velocity is 40.9 meters per second. So that gives me a total momentum, of box 1, which is about 818 kilograms times meters per second. So that's the momentum of box 1 before the collision. So right here, that's its momentum. Box 2 is a little bit simpler, since momentum is just mass times velocity. Mass 2 times its velocity 2. Right? Momentum is mass times velocity. Well, this is 0, right? So this whole thing, 0. So the momentum of box 2 is actually 0. It's not moving in this case. So our total momentum here is momentum box 1 plus momentum of box 2. It's going to be your total momentum, which is going to be 818 kilogram meters per second. Right, so that's the total momentum. Before the collision and after the collision is 818 kilogram meters per second. That's the total momentum of this whole system, 818 kilogram meters per second. So we know then, here after the collision, if we add this momentum of box 1 to the momentum of box 2, we'll get 818 kilogram meters per second. So let's look at the details of the after. Remember, the mass is still 20 kilograms for box 1, and the mass is still 10 kilograms for box 2. And so we need to find the individual momentums of these. And so box 1 is its mass, 20 kilograms, times its velocity, 13.4 meters per second. And that will give me a momentum of box 1 that is 268 kilograms meters per second. Box 2 is moving, so we have its mass now, 10 kilograms, times its velocity. We don't know that. Okay, we're not sure what that is. That's what we're trying to solve for. So total momentum, again, is still add the momentums together. So momentum 1, box 1, and momentum of box 2, add those up and we'll get the total momentum. So we know the total momentum because it's conserved. We know it's 818. So we know 818 kilograms meters per second equals my momentum of box 1, 268 kilograms meters per second, plus, in place of momentum 2, we're going to put 10 kilograms times that velocity that we don't know. That's what we're trying to solve for. So if I want to move this 268 kilogram meters per second away, right, since I'm being added here, I'm going to remove this. I'm going to subtract out 268 kilograms meters per second. I do it over here, right, and I have to do it over here, so subtract 268 kilograms meters per second. Alright, so I'm kind of running out of room here, so I'm going to kind of scooch over here. That gives me, what is that, 550 kilograms meters per second equals, the only thing that's left over here now is the 10 kilograms times that velocity, of box 2. So now I want to get the V2, the velocity of box 2 by itself, so 10 kilograms, we're going to divide that out, alright, and we'll do it to both sides, so that's 10 kilograms. My kilograms will cancel out, and it gives me meters per second, so I get a velocity of box 2 of about 55 meters per second. Alright, so the box over here, because of this force that was applied to it from box 1, made it accelerate from 0 speed to 55 meters per second after the collision. But again, the momentum of the entire system is conserved. So that's how you do a basic elastic collision problem. Alright, again, we're going to conserve momentum. The momentum before and after will be the same.